All right, what is up, everyone? Welcome to week 81 of building my own operating system, formerly known as Chill Kernel Hacking for Fun. And yes, just gonna do my usual setup. Cat Flare immediately here. What's up, Cat Flare? Chat works. Good to know, good to know. What's up, Yazalde? Nice to see you also. Give me a moment. So, yeah, I have a new YouTube thumbnail. I worked pretty hard on that recently. I hope it looks a bit more professional. So I'm excited to release that today. What I think, yeah, I don't know. Other updates, I've been looking into Claude Code a little bit, and I had a pretty good experience with it, actually. Kind of using it to help me debug some stuff with the OS, actually. So that was pretty cool. Got bored, so I'll watch the stream. Nice. Nice, well, maybe we can do some interesting stuff on the stream that's hopefully not too boring. Okay, so let me see. So here's what I've been working on. So for a long time, okay, so here, okay, just recapping a little bit. So for a while, we were doing all these boot experiments, multi-boot, V1, V2, Limine. Okay, then we moved on to getting Clang working and LLVM, and we did that all in this series of work. And then I merged the CMake branch. All of this previous work was all in the legacy make file system. And ideally, I want to move over to CMake. So I merged my CMake branch. And then I'm starting the process of kind of migrating all that previous work with the boot stuff and with Clang into the CMake branch. And that's what we've been working on. And that is somewhere over here. So technically in the CMake branch, I do have the Limine support. And then in this branch, I have the LLVM Clang work integrated into CMake. And then I was third-party DIRs. Okay, this was just kind of a cleanup, basically. Then I have some little stuff, but the more interesting changes I was making recently are... This commit was kind of interesting, using these compiler flags with the goal of optimizing the binary size of the kernel. And actually, this is what I was talking about with the debugging. Turns out I needed to make some linker script changes to accompany these new compiler flags. Let me also reset the break timer. And I actually got a lot of help from Claude Code about this, and it was actually pretty impressive. Claude Code was able to understand the fdatasections flag and then identify the root cause and suggest some linker script changes to fix the issue. So that was pretty impressive. And I'm not going to go full on AI with this project, but I want to find a nice balance of using it in the right way and kind of using it to help me get past things that I'm kind of just stuck on or whatever. So, so that was interesting. Okay, I'm just gonna do a test 2 in the chat because I still don't see anything in the chat widget. Let's go. Hey Bacon. Good morning. What is up? Okay though. Let me see. I'm just thinking about what to do with these branches. So I have the dev branch, has been the main branch, and I have this branch for some debug stuff. I actually just I'm going to rebase this quickly onto dev because for some obscure detail. Oh. Okay, actually that. Interesting. Okay. Oh, I see. The dev branch ends. It actually includes a bunch of stuff already. It includes all this stuff. Okay. Split core. So what I think I will do is I'll try to just kind of recreate this to make the rebase a bit easier. Split core, whip, optimize, use trunk branch. Okay, cool. So now I think what I can do is rebase from here. Yes, okay, so that worked nicely. And now I might just merge. I mean, these are just kind of some random changes, really. Add quad, git, ignore, tool chain, rebuild, and like script. Yeah, what I'm just going to do, I'm just going to merge this whole thing, but with fast forward, I think. Actually, I mean, I might just hard reset dev to the tip of here. There we go. Okay. Because I have some, I sort of want to reorganize a few things here. So we have a bunch of like tool chain changes yet again. What includes the base lib? I forget. So these 4 commits kind of go together. All right, you know what, whatever. I'm not really going to worry about this too much today, like right in this moment. We have more interesting things to do, so I'm just going to confirm the kernel build and runs, and that's great. And while I'm at it, I'm just going to edit my lemine.conf to remove that timeout, which is kind of not needed. So there we go. So now we're booting directly into the kernel. Cool. Lemine, remove timeout. Okay, so now let's get going with the actual interesting stuff that I would like to do today. Also just quickly checking in on stream health. Okay, cool. Also hello to the one person on Twitch. Nice to see you. Okay, so one thing I just want to do is start using LLDB instead of GDB, because the whole idea, refresh, one of the main larger efforts has been to get rid of the GNU tool chain. So getting rid of GCC, getting rid of the GNU bin utils, and we've done that so far, getting rid of libgcc, but one of the last remaining pieces that we are still using from the GCC, the GNU toolchain, is GDB. And it would be kind of nice to just completely move to one tool chain. So that's what I'm going to try to do, and hopefully that should be pretty straightforward. So that's gonna be stop number 1 today. Use LLDB instead of GDB. A little bit later, if we have time, I want to add C++ support to the CMake build, and then later even investigate some freestanding C++ standard libraries to be able to use. But that's going to be available later. So for now, we're just going to work on using LLDB. And the first thing that we need to do is check if LLDB supports the i386 target. Yes. So I have LLDB on my system because it was installed there from Mac OS or something. And I sort of wonder what to do. So I'm just going to open up my devtools.cmake and see, devtools.cmake and see the command. Always wanted to learn LLDB. GDB was my first debugger. Yeah. Yeah, let's do that. I mean, I've used both of them, and they're pretty similar from my usage of it. So, I mean, now that I'm kind of thinking about it, there might be some advantages of using GDB. Like, there are all these fancy Python script extensions for like exploit development, like, I don't know, it's not Pwn tools, it's Pwn debug, I think maybe. And those can be very useful, but there's no reason we can't support both. And so let's just try this out. So what we're going to do is I'm just going to run the kernel with the debug server mode. And then I'm just going to try to do basically the same thing that I would normally do. Target remote, localhost. Some weird GDB. Does this work? Oh, okay. So now I'm going to go into my Claude Code LLDB. How to connect to remote target. I think I don't really need this pane anymore. I was doing some investigations into binary size. GDB remote, okay. And check it out, like, it knows the code base, so it can even recommend, it even knows the specific GDB port, which is kind of cool. So that worked. We connected to, yeah. Okay. And anything else I need? Symbol. So the symbol file thing is kind of important, because without the symbol file, for example, if I try to break on a function name, I can't do that. I can only break on raw addresses because we don't have symbols. Why is my terminal messing up? Okay. How to load a symbol file. What did I just type? Symbol file. Okay, so now maybe this is kind of interesting. Setting the architecture, because I'm actually not really sure how LLDB knew what architecture to disassemble as, because we didn't give it any information about that. Maybe it was communicated by the server. but I don't actually know. Excuse me. Okay, so you can directly just pass it a binary, or you can load target create. So that's something we could try. And that totally worked. And the nice, okay, so it automatically parses the binary, detects the architecture, and presumably sets it. So now we should be able to do things like set a breakpoint. And that worked. And just as a bit of like a commentary on this, like the output and the user experience just seems a bit more refined with LLDB. So I'm just gonna okay, so continue didn't work. Do I have to do run? Bad CPU, okay. Maybe I need to run the GDB remote after target create. So maybe I need to do this. No, it does not fit. Okay, no, it does not seem. Let me how do I even get out of this now? I can stop the job with my shell, but there's no control seeing possible. Okay. Jobs. Kill, was it 1? Grabs. Fish shell, how to kill a job by number. That's sort of what I thought. Oh, yeah, no, I was kind of right, but apparently I need kill, that one was not strong enough. Okay, well, let's try this one more time. So I'm going to start this thing up. I'm going to start LLDB and so this, then I'm going to do GDB remote. And then what if I continue? Okay, that worked. Okay. What can I quit now? Quit. And then it hangs. Okay. Okay. Do I want to proceed? Yes, I did. I do want to proceed. It seems like I'm kind of stuck here actually. So that's sort of not great on the LLDB side. Didn't have these problems with GDB really. Bummer that I need to do that every time. Let me try that one more time. So, I mean, we can start to bake this all into sort of bake this into a command line now with the -O. So now this is pretty much what we want. Okay. And bam, this gets us going. So now if I set a breakpoint and then continue, okay, great, that works. Yeah, LLDB has like some nice colors and stuff. And apparently some underlining or whatever. So that's kind of cool. So now I can just kind of step through and I can disassemble. And that's kind of nice. It supports a lot of the same things, like the syntax of GDB also, so you can do a lot of these GDB commands, and those just work. I can step instruction. Yeah. What I want is generate an LLDB init. does x for I PC at every, using a stop hook to print the next SM instructions. Yeah, this would be pretty helpful. Okay, so that's cool. So anyway, I think I'm, so the only problem was that we couldn't really quit. We can seem to debug pretty well. Oops, init. I can set breakpoints and stuff. But then how do we get out of here? Also, hey Tech Leaf. So I had some trouble. Q. This did not work. Wait, that so now it worked actually. Okay, so that is cool. Anyway, so this is our command. So now I can add a custom target. Oops. Yo, Wizard, what's up? We're gonna add the LLDB target. And toolchain, GDB. I'm gonna keep around the LLD, the GDB support just in case it is useful. But LLDB, and I don't know what these flags are, but we're gonna do something kind of similar. We're going to say, okay, we're gonna pass it the path to the binary, and then we just say -o, and actually it's kind of something like this. Oh. Why? My Vim. Okay, paste. Interesting, that didn't work, okay. So we just do this, and instead of this, we do GDB port, working directory, okay. So now we are like almost there, dang. So LLDB has this weird thing where, okay, no, it was timing out. So now I can do my workflow with like blah, 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 GDB, and then I can do make j LLDB and then start to debug like I'm used to. And look at that, it just looks a bit nicer than GDB. I'll show you GDB for comparison. And symbols didn't load for some reason. Reading, but wait, it should have loaded symbols. Oh, it just took a while, okay. Okay. Sorry, TechWolf, I don't really understand your question. Yeah. Anyway, okay, so that's kind of cool. So we just have our LLDB target, and I'll rename this Kimu GDB thing to Kimu debug. So now the target is called Kimu debug. Why did that not work? Yeah, I don't know. Yeah, LLDB does kind of look better. GDB, they both have like colors and stuff, so yeah. Why don't I just regenerate? Maybe I shouldn't need to manually do that, but apparently I did, so yep. Creating OS or other big projects from scratch. Okay. So the question is, how does working on projects in your free time, like an OS or especially a big project, how does that help you in your professional life compared to someone that does not do these free time projects? It's all about trade-offs, and so if you're not doing these projects, then you have some more time. But if you're doing these projects, then you potentially learn more, and you get a broader breadth of experience. And in my experience with professional work, you can learn a lot, but over time, your learning starts to get reduced, because you just kind of learn the core knowledge needed for the role. And so you can do things to kind of push outside of that and expand your learning. But by default, my experience has been that your learning sort of tends to kind of just get focused and kind of reduced. And then and so to counteract this, you can work on side projects in your free time. And so, for example, I would not really get experience with any of this stuff at my professional job because I'm not a kernel developer. And even if I was a kernel developer, it's very likely that a lot of the core project infrastructure is already done for the project that I'm joining. And so even if I was a professional kernel developer of some kind, I still likely would not be getting the experience of the things I'm doing right now, of like setting up the core project infrastructure. And so these are just all things that I'm getting out of this time that I'm investing into my own learning, basically. So that's sort of how I see it. Okay. So anyway, so we got LLDB working, and the last thing there was this LLDB. No worries, no problem. Happy to answer your questions. So, question for the chat: is anyone just curious? Are people using Claude Code, or this is OpenAI's version? It's called Codex. Just curious. I'm kind of new to it. I'm just exploring it for the first time. But it's sort of just this nice integrated LLM into the terminal, and it's pretty powerful. So for example, I asked it to generate this LLDB init, and it did so. What would be even more convenient is if it would just generate the file. So can you generate this file into my project root? Because that's kind of the point. Like this LLM, not only can it just like answer questions for you, but it can actually do actions. And I actually asked it to generate a file, and it is about to do this, and it's asking me for permission, and I'm just going to say, yes, you can do that. And let's check out what it did. So here it is. And I'm going to, oh nice, it's got the the Intel syntax so I can finally stop using AT&T syntax. Okay, anything else? Show more context. I don't really know these options, but they sound useful. I also don't really know if this one is needed, so let's just give this a try. So we're going to use Kimu debug and then make LLDB. And I'm not sure if that worked. There is, which is not being read. Yeah, only started using stuff like cursor. Yep. So I was doing the same thing. I was using cursor, but then I've been using Copilot. And I think one misunderstanding I had was that I thought that Claude Code was basically like the same thing as cursor or Copilot, but just, or Copilot agent mode, but just in the terminal. But it's actually not. It's actually more powerful than that, because with like agent mode and cursor and Copilot, the paradigm is that the human is doing the work, and then they are supported by the AI sometimes to help them out. But with Claude Code, it seems kind of different. Like, it's sort of like the opposite. Like, you tell it what to do, and then it starts kind of like doing stuff, and then it asks you for input or comments when it needs help. So, okay, 8 bits out, you're using Claude Code. Nice. Yeah, I'm pretty impressed so far, and yeah, I think it'll be a nice complement to like a complementary tool for this project that I'm working on, especially since I'm kind of time constrained. Okay, so apparently I need to it's like some security thing, but in this case I trust, like, I'm not really loading files from third parties. So anyway, 20-second break, be right back. So I'm just going to put this into my LLDB init in the home directory. Let's run this one more time. So, and then LLDB, that's sort of still did not seem to work, because this looks like yeah, this is all still. Oh wait, no, I did this wrong. I need to add true, I think. Let me quit. There we go. So now that's working. So we have the Intel syntax, and oops. And now we set a breakpoint, and I can step through, and I can disassemble, and we have Intel syntax, but my stop hook is not working. Stop hook. Target stop hook list. Oh, there it is. Wait, there it is. Okay, so interesting. Okay, so I don't really know who. More context to this. So anyway, we get a bit of the source, and we also get 4 lines of disassembly, which is kind of nice when you're stepping through the assembly and you want to just sort of get some context. So that's great. All right, well, that's some good progress. So I'm going to first, I mean, I guess all this can all be in one commit. So what are we doing? We are adding a new custom target for running LLDB. And is this actually, it's the GDB one. Actually, we don't need the -J flag. I see, we don't. Or do we? Why did it just build, like, why did it just try to build a bunch of stuff? I'm a little bit surprised by that. CMake, regenerate. When I do make LLDB, that is interesting that it, maybe it's because of this. Let me see. What if we instead just hard-coded a kern.elf? I wonder. So now let's regenerate. To be really safe, let's clear it out and then regenerate. And then, okay, that's what I'm talking about. So with this version, it doesn't do any dependency tracking. Yo, C++, hey Tigra. But with this version, it actually seems to sort of be a little bit smart, and it knows that, okay, this thing is depending on this target or something like this. So now when we regenerate the build, yeah, that's kind of interesting. I guess that's kind of nice, actually. But that does mean that we need to remember to use m-j when we're like invoking this, because otherwise it's the compile is kind of slow. So yeah. What color switch is your keyboard? Hey Simo, color switch is your keyboard. Sorry, I don't understand the question. Okay, failed to connect port. Quit. How do I quit? Okay, so LLDB seems to have some weird things where it's like kind of hard to quit it sometimes. And I guess I can just kill it if needed. So that's great. So let's check this out. Don't need this. Oh, dang. Okay, I just accidentally dropped that change. Is there any way to get that back? No, I don't think so. Ouch, okay, that was kind of stupid. I'm gonna recreate that quickly. Wait, that was kind of weird. I meant to only drop the unstaged change, but kind of dropped everything. Okay, so LLDB. This, and then we're going to use -O, and it is going to be oops, GDB remotes. Yeah, that was about right. All right. Sorry about that. Let me just. Oh, what? No. All right, something got kind of messed up. Why? Oh, wait. I need to debug. That was changed here too. Very interesting that. I would expect these changes to automatically, if I change stuff here, it should automatically regenerate the CMake build, but it seems like it actually doesn't. And that's a bit mysterious to me. Hey, Az, anything? Nice to see you again. What's your IDE and AI integration I'm using? So I'm not using an IDE per se, I'm using VS Code, mostly as a text editor. Then I'm using Kimu for emulation and normal toolchain tools. And then I'm using Claude Code for the AI at the moment. Okay. So here's this, and then let's get back here, and that works. Nice, that all works. So good. Let me not drop that. So adding the new target, changing the name to be debug, adding just this thing, and then I'm going to remove a couple of these comments which are not really needed. I'm going to group these things together. This seemed to not be necessary, so I'm going to get rid of it. This shows some registers. I don't really want that either, and I don't really need that. So I'm going to move this to the top, and this is what it's going to look like. So that's cool. Disassemble C4-S. Okay. And I'm going to add a commit, and it's going to be the tools add LLDB support. Nice. So that's great. And that is our first task of the day. Done. Okay, so now we're going to move on to hopefully a bit of the more interesting stuff. So add C++ support to the CMake build. So hopefully this should also not be too difficult, because we already got this working in the make, like in the make file build. But you never know with these kinds of things, and also it's CMake, so maybe there are some little details we need to take care of. So to start out, let's just check out how did we do this originally? Meaning, yeah, originally meaning in the make build. So I'm going to go back to the history, and I don't even see it. Why not? Okay, where did it go? Make file, CXX. Yeah, so something in some, oh, it's in the branch. it's in this branch. So let's take a look at the branch. So in this branch, temp fix, what is that? Okay, so that is kind of random. So here was our commit that adds C++ support. What's this branch? This was the first attempt, but that was sort of a misguided attempt. Actually, this one is the better one. Okay, so mainly the important part, we have the C++ compiler, G++. We have a variety of flags that are needed. And then we basically just added all of the C flags except for GNU 99. Okay, this was all like a bit messy. And then we made the CXX flags thing, which is basically the same. And what that allowed us to do, okay, is over here, we're now able to use C++ files, and this is kind of a random detail, and we just have this simple rule that makes use of it. So I think that's kind of the idea. And okay, this is the kind of thing that I would be curious to let Claude Code try. Yeah, let's just try that out. Hey, what's up, Pac-Man? So let's just see what Claude Code can do here. I'm going to copy the hash of this commit, and I'm going to say, okay, new task in, why did that commit not copy? Man, that's annoying. Okay. Okay. C++ support was added to the legacy makefile build system. What do I want to say? I'll also make a pane to help keep my video window out of there. So, okay, new task. And that I want to replicate that work for the CMake build system. For a first step, I just want to be able to add a CPP source file to the kernel and have it build with the kernel. What's our tool chain look like? So we use Clang, so we're going to use Clang++. Please use Clang++ as a compiler, C toolchain.cmake. I'm just gonna say that. So now it's presumably, it's like doing some git commands to read the git history. That's interesting. Okay, then here's the part that's cool. Here's the part where it's suggesting changes and I can accept them or not. And in this case, that looks exactly like what I want. So I will accept the change. Actually, I don't know what that does, but maybe it's time to find out. And I mean, I could just ask the AI again, but maybe I'll just check the docs quickly. Or, oh yeah, what if I just say, no? Before I accept that change, can you explain what and do? Oh, interesting. To skip compiler testing. Okay, interesting. Usually in normal application development with normal build systems, it tests the compiler and just tries to like run a simple program just to make sure things work. But in this case, it's going to try to use the cross compiler, and that will not be able to run on the host system. And so, okay, yes, please do that change. So now does it know to like resuggest that change? I hope so. Okay, yes, cool. So now it needs to do some C flags stuff. Interesting. Okay, so let me just pop into here. So in our C flags, okay, nice. For some reason, so the make file build system had the GNU 99 flag. For some reason, I got rid of that in the CMake build. Or that seems to be just completely gone from the CMake build. So that's actually good, because that's the one flag that cannot be used and passed to the C++ compiler, but it's not here. And so we can just basically we can construct the CXX flags from the base C flags and these other specific things. That looks perfect. I'm gonna accept that change. So now it's going through here and it's finding the place where I declared the kernel C flags, and it's going to try to do the same thing. Looks good. So then here's the part where like it starts to get out of my knowledge about how to, like all this language stuff. So apparently you need to enable the language in the main CMake. So I'm just going to accept that. Sounds right. Okay. So now it sort of like took the same C++ file from the legacy commit, and it is replicating it, and it's going to create it in kern test. And is that the right place to do this? Yes, kern is just this big file this big pile of files. So yes. Okay, so now it's I think this part was also in the legacy commit, but now in addition to having a C++ file, we're adding a function in the C++ file that will be called from the C file. Yeah. All right. Hey Zardas, how many Pomodoro sessions do I do per day? Yeah, no, it's not a digression. I'm happy to answer questions. I don't do Pomodoro. Yeah. All I do is I just work with this 20-second break timer, and I take a break every 20 minutes. I take a 20-second break for like eye health reasons and standing up and just stuff. Okay, so now we have this. Yeah, so that's just what I don't really do Pomodoro. Okay, so basically it added this C++ file into the list of source files in the build system. And then here's the part where, what is this doing? I think it is kind of like testing something, like if we're using C as the language, use the kernel C flags, otherwise use the CXX flags, and that's something I would not have been able to do on my own. So that is super helpful that it's suggesting that for me. Yeah, that's actually kind of interesting. So what does this line do anyway? Target compile options. This is the line. So the way CMake works is you have these targets, and they're kind of like an object. And with this kernel elf executable, and we add all these source files to it. We give it some dependencies, so it's going to depend on the CC runtime lib, but also the base kern lib. We pass some link options, and then some compile options. And so these compile options are going to be used when compiling all of the source files. And so far it's been okay to just simply pass our kernel C flags just to everything. But now that we're using C++, we have these two sets of flags and we need to differentiate between them and choose the right ones. So apparently that's how you do it. Did not know that. Okay. And then now it's kind of completing the test. So this is all based off of code I wrote in the legacy commit over here. Basically, like I wrote the C++ file, and then I have this header file with the include guards in the right way, and then I'm just trying to test it out and make use of that C++ file here. Okay, yes. So yeah, I have to say this whole command line experience is pretty nice. I mean, it just looks nice also, with like they're really using the colors and the highlighting and stuff. So now it's actually just, it's trying to like really run things. And I think that's the part where I can take back over. So let's see. So I'm going to, first I'm just going to build the kernel, and that did not work. but we're here for a 20-second break, so feel free to join me for a quick 20 seconds. Okay, this, so when we tried to build the C++ file, or maybe not, let me clean the build. Let me run this without parallelism, because the interleaved output sometimes makes it hard to understand what's going on. Right. So trap. Let me go back one more step. So what happened here? So this is all the stuff that we saw earlier. It seemed correct. This seemed right. Adding this thing. It added a new line at the end. It's funny. I forgot to clean up the new line. And we have all this basic stuff. So that all seems right. So this is kind of interesting. And before I let Claude Code try to debug this compile error, which might be kind of interesting to observe, I'm just going to see if I can do it myself quickly. So it's trying to build trap entry .s, which includes pick irq.h. Okay, which has this specific check that requires the JOS kernel defined to be enabled. I see the problem. Okay, so previously, so the problem is with this thing. Previously, we were just passing these C flags to absolutely everything for both .c files and .s assembly files. And the key part of the kernel C flags is that it has this djos kernel macro that is defined. And so previously, every single thing was getting that djos kernel macro. And then this file is actually checking that this macro exists, and it's not allowing files, like compilation units to like use this header if you don't have this thing. And what changed is then we broke this apart into C and C++. And what we're missing is actually the assembly compile language. And so now the assembly files are not getting any of the C flags, if I understand correctly. And that's causing this to fail. What's up, Nikolos? And Minsky, nice to see you. I'm really excited for you to join. Yeah. Yeah, cheers. Nikolos, we are working on adding C++ support to the kernel right now. Basically just means I want like the kernel's like all in C at the moment, and I would like to be able to use C++, and so we're just going to add support for kind of incrementally using C++. Yeah, thanks a lot, Minsky. Yeah, huge shout out to Minsky for creating all these useful tools. So for anyone that doesn't know, Minsky is the creator of Limine bootloader, which I'm using, and also CC runtime, which I'm using, and also like a bunch of other utility things like freestanding C headers, and pretty soon I will be using freestanding C++ headers. So Those are all super helpful projects. So okay, so basically I know the fix. I'll just quickly add it just to test that out. Current CMake lists. So we have this, and I'll do the SM, and we'll just do the same thing for any assembly files. We're just going to also use the kernel C flags just like it was previously. And I'm pretty confident that this should fix the build. Yeah, I mean, yeah, the LLVM devs wrote compiler RT, but I mean, you did the work to make the CC runtime project. Like, it would be kind of annoying to have to repackage that yourself, so that's still useful. So apparently, oh, interesting. Clang plus unknown argument f no leading underscore. That is interesting. And toolchain.cmake, no leading underscore. So no leading underscore was a flag I needed for GCC or G++, but maybe it's not a thing with Clang? I don't know. Ugh, okay. Oh, interesting. Sardis. I don't know. I would say Minsky has a lot of online proof that they know a lot about kernel development. So for some reason, all these linker flags are being directly passed to Clang++. Yeah, Minsky, I think you're right. Why? Let's see. It has to do something with this. So, okay, just for understanding, I'm just going to do a verbose build so we can see the command lines. So, yeah. So here is the actual full command line. And yeah, so what we're seeing is, so first of all, Clang++ is being invoked. And so that's the compiler. And these are all linker flags that are being directly passed. Right, and so that would be one way to fix the problem. And the reason I'm hesitating is because I think the C files do it kind of differently. Let me trigger a plain C file compilation. So what's like a basic C file? I mean, it doesn't really matter. I could just kick this off and just stop it. Or maybe I could, that was maybe a bit too early. Let me keep it going. Okay, I'm gonna stop it. So, I was trying to find, this is kind of a dumb way of doing this. I'm just gonna let the build run and then, what about here? It's building all this user space stuff, which I don't really care about right now. Right. I mean, yeah. So, but yeah. So Minsky, yeah. Like, so we need to pass the prefix correctly. I don't know how to do this with CMake. Do you know how to do this with CMake? I suspect there's something with this target link options, like in the same way that we needed to do something, you know, with these compile options and kind of separate it out per language. I sort of am thinking, yeah, right. Yeah, what? Have I considered Meson? Actually, yes. I did a bunch of experiments with Meson, and I chose CMake in the end. And I think, I don't remember my main reasons. I found the dependency thing with Meson kind of weird. And I also did not find the support for, like, it was either cross compilation or building host tools was a little bit difficult. I would have loved to use Meson. Like, I think the Python is way better than the CMake language, but there were some things I didn't really love about it. Also, the sub projects thing was like a little bit odd to me. So yeah, I did give it a look, but I decided against it, for better or worse. Okay, let me do this. So kern, I'm going to try to find a way to, what's kern? Where are all my object files? We're in the builder kern CMake files. Here we go. So I wonder if I could console.c.obj, for example. Previous chat message was shadow banned. Oh no. I don't know. Yeah, sometimes that happens. I don't know if you sent a link. So links have been kind of weird with YouTube chat. Just for fun, let me, can I do this? So let me, console, see that obj. I think it's something like this. So here, I'm just looking for an example, or console.obj. I'm just looking for a way to simply build a target. PMAP, maybe PMAP is a nice, pmap.obj, or maybe I need to specify this whole thing. Anyway, my goal here is I just want to have an example. I just want to see what the compile flags, like the compile process looks like for a normal C file, to see how we handle this linker thing. And the funny code website with the cat mascot. Dang. I mean, I think links, I think it doesn't allow links or something. I've looked for settings to like enable that. But if you want to, if you want to post that, you can break apart the link, you know, into like with spaces and stuff, and maybe that will not get banned. Okay, let me just build let me verbosely build the kernel elf, and that will give us a bunch of these things. Yeah, I really, if anyone knows how to change that, I've looked everywhere and I've kind of struggled to find out how to make links okay. There's a Meson template. Let's check that out. It's on GitHub, right? Lemine bootloader. Or do you mean on Codeberg? I see, okay. Right. Okay, well, good to know. Yeah, I didn't see this when I was looking through things. But, okay. Yeah, I know some other projects use Meson, like Managarm uses it. Yeah. Yeah, I think that ship has kind of sailed for me, unfortunately, but but good to know. Anyway, let's just take a look. So, I mean, here are just some normal C compilations happening. And what we can just... Holy crap. I mean, yeah, this is passing like all these linker... It's passing like all of the linker flags. I've never used auto tools, so I don't know. But I've had reasonably good experiences with CMake. I know other people that have too, and apparently it's some industry standard thing or something. So yeah. Okay, here's where I'm going to probably use AI, I think. So, okay, so now, I mean, I kind of know the problem. Thanks for all that. I have a problem though. It seems like the full set of linker flags are being passed directly to Clang++, which errors the build. The C build works differently. Somehow, linker flags are only passed to the linker. Yeah, I mean, I'm just covering my bases. You never know what's gonna happen. Okay, somehow linker flags are only passed to the linker and not to the compiler. I suspect it is something to do with target link options for kernel elf in kern CMake lists.txt. Any ideas? You're absolutely right. Okay. Oh, interesting. Yes, that would do it. Okay. So the way this works is we actually have this variable that controls how these compiler or no, like linker commands look. Wait, what? Without, wait, okay, no, wait, I have a comment here that I wrote explaining this. So without this, it tries to use the Clang compiler driver to link, which doesn't recognize the various linker command lines we pass. That's exactly the issue we're seeing now. And so when you set this variable, it kind of overrides that behavior, and it doesn't automatically use the compiler driver to link. All right, feel free to join me for a 20-second stand up and stretch and whatever. Yep. All right. So let's add that. Okay. So now things probably work if I had to guess. Okay. Make J. Ooh. Oh, this is interesting. But yeah, so that fixed the previous issue. So now we have a different issue. And what is especially interesting about this is that I did not run into this previously, I think. Yeah. Like this is, so now the build is kind of working actually. So this is a linker error. Yeah. The thing is, I literally was in the previous version of the C++ branch, which I got working. I tried to make a pretty complete C++ example that I explicitly wanted to use virtual functions with, and I did not need to do to add that function. CX pure virtual. Yeah, so I don't know what happened there. I don't know if it was a GCC thing that allowed me to not have that. Also, what's up, John? Nice to see you. We got a really stacked chat today. This is great. Nice. All right. So anyway, yeah. So that is interesting. Let me simplify this example though. I feel like that's kind of jumping a few steps ahead. I just, for the moment, I would be totally fine to not use virtual functions and just do a basic test of just compiling the file as C++ without particularly using any features that are super C++-y. So that worked, and entering C++ test, C++ test complete. So that worked. So we're doing some C++ stuff. And that is great. I don't know, just as a quick example, I'll just use a reference or something like this and just observe that working. Func. I don't know. Something like this. Yeah, yeah, no problem. That makes sense, John. So I don't really know what I expected to see, but yeah, this is working. So now, I'll make a commit first of all. So we need this. I think we need this. Unfortunately, there are some spaces there. All right, question for the CMake pros out there like John. I spent a little bit of time looking for auto formatters for C++, but I didn't find anything that like looked good really. So yeah. All right, nice to see you, Minsky. Thanks for joining. Have a nice one. Oh, white space. CMake format. Yeah, I thought the CMake format like looked pretty bad. So that's why I kind of didn't use it. I just thought the styling, like it also, like a CMake format doesn't allow you to have new lines here, like within a variable declaration. And that was kind of a deal breaker for me. I feel like I sort of benefit from having the ability to do that. So yeah, unfortunately did not love that. And so now I'm sitting here cleaning up white space. Okay. Yeah, I like looked through the JSON config or whatever it was. I didn't immediately see anything that could solve that. It has like some similar stuff. It has some options for controlling white space between these top level statements, but I didn't see anything for like these internal white spaces. So yeah. Metaverse bit, what's up? Are you using macOS and trying to build an OS? Yes, macOS is my developer system, but I'm building an OS for 32-bit x86. David, where do I start to understand this? You can check out my resources page, which is a kind of just a random list of links. But yeah, I mean, why not Linux? I don't use Linux as my main system because I don't have time to use Linux and debug all the BS that comes with that. And I just want to be able to run software and I don't know, live my life. So, okay, I'll just yeah, so okay, so with this commit specifically, why? I might skip a few things. So I'm gonna not commit those. I'm just gonna commit the basic example. And then we'll add the virtual functions later. But this was needed, so let's add basic C++ support. Okay. And then now we need to add the virtual function thing. Yep. So let's do that. Okay, so here's my animal example. And it's not going to build. So we need to define this symbol. Also, why is it asking for operator delete? And also, why did we not? So all sorts of stuff I didn't need before. But I mean, maybe, yeah. So that was with GCC is when I was doing it. So why C++ over C? I don't really know C as a language. I know C++ way better. And there's a lot of nice language features you get with C++. So that's why I sort of thought it would be nice to be able to use it, if possible. Yes, I have disabled RTTI, I believe. No RTTI, no exceptions, blah, 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 blah. Okay, so maybe one step at a time. CXA pure virtual. That you can't have polymorphism without RTTI. I don't think that's true, actually. Are you completely sure about that? That's not. I think. I'm not sure that's true. I think you still can't have virtual functions without. You can't have dynamic cast without RTTI, but I think you can do virtual functions. And also, what's up, Ismail? Thank you for the thumbnail compliment. Yeah, I worked kind of hard on that over the last couple of days. Fancy thumbnail. Okay, so let's pretend. I mean, let's just try adding this. So I should probably panic here. Can I panic? How do I, where does panic come from again? Assert.h. Okay. Okay, just to test this. Yeah, with all due respect, I still don't totally believe you. That's nuts. I'm not totally sure about that. Okay, so this worked at kernel panic 1, 2, 3. And notably, it compiled and ran. Yeah, I mean, to be honest, I don't really have a great understanding of RTTI, but I'm pretty sure that like dynamic cast relies on RTTI, but virtual functions don't. But I'm happy to be fact checked on that if someone wants to do that. But okay, so that, but I mean, yeah, adding this thing worked. It compiles now. And the only remaining thing is the delete operator. which apparently these destructors, but also I think I kind of did this wrong. Virtual, yeah. I mean, that's true. You only use dynamic cast with polymorphic types, but right. But you don't have to use dynamic cast. You can still use virtual functions without using dynamic cast. I think I did this wrong, actually. I think I had, like, wait, what? Temp. Okay, this fix makes no sense. You're supposed to have virtual destructors. Is it possibly related to this? No. Delete. What does the OS Dev Wiki have to say about this? But the thing is, I don't really want to use new. Okay. RCTI, let's check out what the OS Dev Wiki has to say about this. Type ID and dynamic cast, disable it. Note that virtual functions work without RCTI. So I think that's why I believe that. Why is I don't really understand why it's even being invoked in the first place, and maybe I will just ask. Don't call virtuals in constructors. I'm just going to ask. Kind of an annoying thing. How do I would like to dang, I want to add some more context, but I can't add a new line easily. Okay, but it is suggesting some stuff. Does alt? I was trying shift, but maybe, okay, I'm going to accept the change. You said alt enter? No, alt enter submitted the message. Types for size T, interesting. Is that actually true? It's right. It's right. Okay. So that almost worked, except not. Wait, that's kind of confusing. Why? Size, you need to include for size T. That is kind of messed up. So I mean, this types.h is not going to work because that's like the C types.h. I mean, as like a super quick hack, I can just copy and paste this line in. Wait, sorry. And oh my gosh, how do we, yeah, we just don't have any nice things somehow. There's no c_std_int here. Yeah. I mean, eventually when we use the freestanding CXX headers, eventually I want to use this project. Wow, why is it not? Codeberg. Eventually I want to use this project to get the freestanding. So this will actually allow us to have some headers to use. Right, I'm just going to kill the palm tree. But for the moment, I'm not going to do that. So first parameter must be of type size t. Okay, so that almost fixes it. It should not return unless it is declared throw or no except. Just gonna do no except. Sorry. What? Does not match previous declaration. Wow. Okay. True. Yeah. Good point. All right, check that out. So now I'm just going to add the panic here again, and we should be able to observe the C++ code running with virtual functions. Check that out. Okay, entering C++ test, blah, blah, blah. I'm a dog, I'm a cat. Test complete, panic. So check that out. We are rocking and rolling with C++ support in the CMake build of the kernel. So basically what the code does, like, so I make these two objects that both inherit from the iAnimal parent class, and then I'm just running the func on both, this func on both of them, which calls their hello virtual function, which dispatches to their implementations. So that's cool. My remaining question, I sort of wanted to understand why delete was even being called, though I don't. Okay, this works, but why was delete even being called here? I don't really get that. Mark Strustrup. Yeah, I wish. Yeah, no, I'm kind. Yeah. Okay. And that's sort of like the basis of my question. It's like, okay, I can understand why the delete operator might be called if these were heap allocated objects, or like if the new keyword was used or something. But this is all stack based. Okay. So when you have a virtual destructor, you get a deleting destructor in addition. It calls the regular destructor and also calls delete. Okay, doesn't know And compile time, so it always generates the deleting destructor, even if it won't be reused. The deleting destructor references it. Okay. That's why even simple virtual inheritance in kernel code requires the runtime operators. Get pulled in, not, okay. Well, good to know. Any idea where using interfaces would be useful in the kernel? That's a good question. If I were to like rephrase the question a bit, I mean, interfaces and virtual functions are, like the core concept behind them is runtime polymorphism, where you want to basically like have a function or a class or whatever, and you want it to be able to operate on a variety of different concrete implementations of the same class, but with a single kind of generated piece of code. And this is concretely useful. I can name at least probably, so the one example I can think of is for implementing file descriptors, because that's like a classic example of runtime polymorphism in like Unix and POSIX, because like, I mean, you can kind of even see it in all the APIs. You get a file descriptor. What is it? It's read, write, close. And these things all take a file descriptor, and that's sort of what I mean. It's like a single piece of code. So these are all singular functions, but they operate on a variety of different objects, because file descriptor could correspond to like an actual file or a socket or I don't know, like a FIFO or whatever, or there's like a lot of different kinds of things you can get file descriptors for. And so that's one classical example I can think of. Another one is potentially the like driver framework, where you might have a variety of driver classes that all implement the same driver interface, and you might want to have generic code. Yeah, what's up NSG? With NT you have objects. Right, so NT uses this kernel object-based approach. Yeah. Yeah, so I mean, there are probably others, but this is at least one big one. The main kind of situation where this kind of thing is useful, it's really, you need to have, the behavior needs to depend on, like it needs to be only known at runtime. That's a key prerequisite for a valid use of runtime polymorphism. Because if you for example, like another example might be the scheduler. You could imagine like a bunch of different scheduler implementations, and you can imagine like an abstract interface for like scheduling or something like this. And then you could have like a round robin scheduler, and then you could have like other ones. You could imagine, and you could have like, I don't know, like a fancy real-time scheduler or something like this. But actually, I don't think this would be a good example. Like this would not be a valid use case of runtime polymorphism, because it would only be useful if you are planning to swap out like the scheduler being used at runtime, basically, which is kind of a weird feature. So I probably wouldn't do it that way. And for me, the scheduler would be an example of something that would be selected at compile time. And if that's the case, then runtime polymorphism is not going to be a good fit for you. You're going to want to use compile time polymorphism. But yeah, apparently IOKit and like macOS or whatever, like they use a lot of this stuff in the driver framework. So that's sort of why I had the intuition around that. Yes. So good question. Yeah, good question. I don't know. Yeah, I don't know if it would be used like everywhere, but it's useful to have around. And one final reason why I think it's a nice feature to have is also for testing. And so it allows you to have like some code. I don't really know. It doesn't matter. You have some code, and then you can take a argument. Maybe it's better to make this a real example. Like this is maybe a bad example. Or actually, no. I mean, this is not necessarily in the world of operating systems. But let's say you had a like a database connection in some code, and you had some code that that needed to use a database. What you could do is you could use an interface there. This is kind of a classic example. And you write the code in terms of the abstract interface, and so you have the function, and it's like con.connect or con.query database or whatever. But the thing is, you're coding in terms of an abstract interface, and the nice thing this lets you do is that in the production code, you can have like a real DB connection that's like the production connection, and you can pass that to this feature. But in unit tests, you can have like a fake DB connection that doesn't actually connect to the network or whatever, and you can instantiate the object with this, and then you can run tests on the and you can still test this code, but without requiring like all the surrounding infrastructure. So that is another example of how this can be useful. Yeah. So, I mean, you can do all of this in C. It is just incredibly verbose because you need to create your own vtable, and it just requires using a lot of function pointers, and you need to make your own vtable, and then each object needs to like have a vtable, and then whenever you want to use, like for example, the C version of this would look like, it would be like you would get like so first of all, you don't have references, so it would be like an animal pointer, like a struct animal pointer or something like this. And each of these animal pointers is going to have like a vtable. They're often called ops, and it's going to be a table of function pointers. And you need to, I'm not super familiar, but you need to like get the function pointer table. No, it's like you get the ops, and then you can call like hello, something like this. And so it's just like you just need to manually do all of that work with function pointers and stuff like this. And it's just way more cumbersome. And with C++, the compiler just generates all of that for you, and you can just do stuff like this. All right. Yeah, so that's cool. So we made some progress. Going to get rid of this. So yeah, I mean, this is something I can clean up later. I mean, ideally, all of this stuff goes into a separate file or even library. Okay, this is, what is this? CXX runtime .cpp or something. And so panic must include std.io, so we don't need this here, and we don't need any of this stuff. Okay, so now we have I mean, maybe I should even panic in all of these. Actually, yeah, let me just panic, delete not supported, shit. Okay. What does this function even do, though? What was that explained? Runtime error handler for calling pure virtual functions. Interesting. Oh, so on the off chance that a pure virtual function gets called, it calls that function, which should like error out or something like that. Like under all normal circumstances, you should not be able to call a pure virtual function. I don't really understand how that could actually happen. How can a pure virtual function even get called? It seems impossible, yeah. Oh, during construction. It winds up in the V table when you specifically delete a method. I've honestly no idea. I don't know that much about this. Can actually get called at runtime. Okay, what base setup? Oh, wow. Okay, that's weird. Okay. If you manually force it, apparently you can manually try to force it to call the base, which you probably would not ever want to do. Partial function pointers. Function pointers, oh my god. Okay, so apparently there's a bunch of exotic situations. Never call virtual functions from constructors / destructors. That's interesting. Okay, I did not know that. But the more you know. Okay, so that's interesting. So anyway, so we have this file, and we probably need to make a header file. Oops. Header file. And okay, so I sort of don't know if this will work, but whatever. And then actually, I guess in here we could include CMake runtime.hpp or something like this. We don't need this anymore. And then now in test.cpp, we include CSX runtime.hpp, and we can not use this stuff. And this thing is our toy example. And I wonder if this will work. Let's see. Oh, that did not work because yeah, in the CMake lists, I need to, oops. I mean, ideally, I would move this into a library of its own and then link against that here. But for the moment, I'm just going to include it right here. And that worked. So that's kind of cool. Test.cpp. So, oops, I just. Nice, okay. So we have this thing. I'm just gonna do this. And our basic example is working. Let's take the panic out. It's sort of annoying that we get these squiggly lines, especially since it seems like we're following. Oh, wait a sec, but oh, it sort of sees, like, we are weirdly defining size t to be human 32. I don't know if it sees through that somehow. Yeah, try hard. Yes, I would say yes. C++ is hard. Yeah. To do this isn't great. Why isn't it? We should ideally not declare our own size t. I don't know the solution for this at the moment. It's probably it will all shake out once we start using freestanding CXX headers. So yeah, why am I defining my own types and not using std int? Because there's just no, so for the longest time, there wasn't a std int. And that's just how the OS was. There were no toolchain headers being used. And so I guess kind of like for legacy reasons, there was just like a types.h that everything included because there were no toolchain headers. But it would be good to change that. And I did include freestanding C headers pretty recently because CXX runtime needs it, or no, CC runtime needs it. Yeah, CC runtime depends on the freestanding C headers. So those are technically available now, but I just didn't get around to doing anything with them. So, yeah. All right, well, I think, well, check that out. I mean, we made a bunch of progress today. We got LLDB working. We got C++ support in the CMake build, and we did not do this. I guess this will be for next time. Investigate some of these freestanding or embedded C++ standard libraries. So that'll be for next time. Good progress though. All right, I guess it's time for like a little commit or something here. So this commit is C++ add support for virtual functions and basic C++ runtime stubs. Right, that's what this looks like with the file, header, and our fancy C++ file. So sneak peek, this is all setting us up to try out some fancy stuff like this frig library, which I'm kind of curious about. It's like this C++ standard library that seems to include some nice stuff, like optional. Yeah, I don't want to write this stuff myself if I can avoid it. Get some containers, stuff like that. And so now we're getting prepared to be able to use stuff like this. All right, so thank you for joining. That's gonna be all for today. Please subscribe to my channel if you're into this kind of stuff. Join the Discord. Let me link the Discord. Yeah, wow, 19 people in the chat. It always spikes at the end when I have to leave. So yeah, join the Discord, and I'll see you next time. See you next week, and we'll get into some more C++ stuff. All right, have a nice week, everyone. I'll catch you later. Peace.